Okay, we're going to go over conversion factors today. We're going to be using these for stoichiometry, but I'm going to go over the 3 conversion factors that we'll be using first, and then we'll kind of slowly work our way into stoichiometry. First of all, there's a new term that's new to you, that's a chemistry term, and it's called mole. It's just the measurement of an amount of a substance, or not any substance. It's abbreviated MOL. So when you hear me talking about moles or comparing it to moles, that's what I'm talking about. It has nothing to do with the animal. Okay, so the first thing is Avogadro's number, and that is a constant. It is 6.022 times 10 to the 23rd atoms, or they can use the term particles. Those can be used interchangeably, in 1 mole of anything. If you forget that number, it is on the front of your reference table. So this conversion factor will get you from atoms to moles, or moles to atoms. And you would just set it up 6.022 times 10 to the 23rd atoms. And that's always to 1 mole. So if we said atoms of HCl, that would be in 1 mole of HCl. It doesn't change. It wouldn't be different if it's just chlorine or if it's just hydrogen. So it's always 1 mole of the substance to 6.022 times 10 to the 23rd atoms. Next thing that we are going to talk about is molar mass. Okay, so that's 1 mole. And then you set that to the grams of the substance. Okay, so the grams, to find the grams, you use something called formula mass. So you add up the atomic masses. So if we are still looking, let's say, at the substance, if we use HCl, we put grams of HCl here. So the formula mass, we're going to look at the periodic table and find the atomic mass of each one of these substances. So hydrogen, if you look on here, it says 1.0079. For the most part, and we have one of those, we're going to multiply it by its atomic mass. For the most part, hydrogen is always just rounded to 1.01. Okay, so there's only one of those, so it's only 1.01 for hydrogen. We only have 1 chlorine, so we're going to multiply that by its atomic mass. Chlorine's atomic mass, if you look right here, is 35.45, so we're just going to round that to 35.5. So 35.5, and we're going to add these two together. So it should be 36 point, so it's 35.5, in case you get someone doing, plus 1.01. Okay, so we're just going to add those together, so it's 36.51. So that number will go up here, 36.51. So you just get the formula mass. And that's whatever the grams is. So you just take atomic masses and add them up. So molar mass is going to get you from moles to grams, or grams to moles. This is for the same substance. Avogadro's number is for the same substance. So it doesn't matter if you're talking about HCl or you're talking about H2SO4, or you're talking about lead, just Pb. It's always the same substance. It's always set to the same substance. Both of these are always set to 1 mole. It doesn't matter if this is written like that or if it's got the 36.51 grams of HCl over 1 mole. And when we get into stoichiometry, I'll show you when you flip-flop those. Okay, so now this gets you from atoms to moles or moles to atoms of the same substance. This gets you from moles to grams or grams to mole of the same substance. So we've got Avogadro's number and we got molar mass. The last conversion factor is called mole ratio. So for mole ratio, you have to have a balanced equation. So if we're still working with the same substance I've been talking about, HCl, that had to form from hydrogen and chlorine forming HCl. Okay. These are not balanced. You have 2 chlorine and 2 hydrogen over here. So you have to have 2 of each one of those over here. So we're going to put a 2 coefficient there. So now they're both balanced. Because that 2 multiplies through everything in it. So the mole ratio just relates moles of one substance to moles of another substance. So this will get you from moles of one substance to moles of another substance. Now before that, same substance, same substance. So it's just like if you're setting up a ratio like you have done in so like you've done in math classes if you've ever set up a ratio. So we're just comparing something to something. So for this, let's say we want to go from moles, or we want to compare moles of H2 to moles of HCl. All you're going to do is look at your balanced chemical equation, and you're going to look at the coefficient that's in it, and that's what your mole ratio will be. Okay, so that'll be the numbers you put here. So if we look at moles of H2, we look up here. H2 doesn't have anything in front of it. That's just 1 mole of it. This, if we look at HCl, it's got a 2 in front of it, so that coefficient becomes the number of moles that we have of HCl. All right, so 3 conversion factors. One gets you from atoms to moles or moles to atoms. This one will be the least used. We will work out some problems with that, but the most used ones will be molar mass and mole ratio. Remember to use mole ratio, since this has mole ratio, your given has to be in moles to use mole ratio. All right, so your given has to be in moles to use mole ratio. So that doesn't make a lot of sense right now because we've not worked out stoichiometry problems, but that's just something to keep in the back of your mind. Your given is the number you start out with. Okay, so that's just the number you start with. If it's not in moles, and you need to go from moles of one substance to moles of the other, you first have to change it into moles, then use the mole ratio.